video, I'm going to show you how I made a recoil for my Honda 3-wheeler from a one-way bearing, a few ice cream pails, and some scrap steel. Since the one-way bearing is the one part I can't change in any way, all the other parts had to be designed and built around the one-way bearing. If you notice, the one-way bearing has key slots cut into it. The keyways will keep the bearing from spinning inside or around other parts of the recoil while turning over the engine. First off, I needed a way to connect the bearing to the bowl on the engine. For that, I was lucky enough to find a piece of structural tubing that was 52mm on the inside diameter. That's the same as the outside diameter of the bearing, 52mm. The pipe tuned to fit snugly on its own around the one-way bearing, so it didn't require any machining to the inside of the pipe. However, the edges were a little rough from where I cut it off, so I lathed it down until the edges were straight. I also shortened the segment of pipe to about 0.6 inches, a little wider than the bearing. The next part needs to be an adapter to fit from the pipe to the bowl on the engine. I wanted something strong enough to be able to turn the engine over, yet soft enough that it wouldn't wear down on the bowl on the engine, just in case some of my measurements were off and the recoil didn't line up perfectly with the engine. That way, the slight pushing or pulling on the recoil would only wear on the recoil parts themselves and not on the bowl on the engine. Since my design has the outside of the bearing spinning instead of the inside, the adapter rung from the pipe to the bowl will have to withstand the force of spinning around 8,000 RPM, the maximum speed of the engine. I decided plastic would be the best material to use, soft and easy to work with, yet durable. Since I couldn't find a solid piece of plastic large enough, I decided to melt down some ice cream pails and make my own plastic pieces. First, I found a 3-inch diameter soup can to act as my crucible. After turning the burner up as high as it goes, I cut the ice cream pails into small pieces and slowly put each one into the can, giving each piece enough time to begin to melt before adding the next piece. After I had several pieces melted, I turned down the heat to medium-high. Otherwise, as I found in my first batch, there tends to be bubbles that coagulate inside the melted plastic from the overheating. Speaking of my first batch, in several areas of this video it shows me working with blue plastic instead of white plastic. The first batch turned out to be blue plastic because the color came from the ink in the labels, which I may have left on the first time. Between the bubbles, the ink, and the paper in the blue plastic, it was rather brittle. That's why I made a second batch of just white plastic. I worked the white plastic the same way as I worked the blue plastics, so there aren't any differences there, I just didn't feel the need to video everything twice. After I had all the plastic melted, I turned the heat off and let the plastic cool inside the can. After the plastic cooled, I was able to turn the can upside down and the plastic fell right out. I used a faceplate and a few screws to secure the plastic to the faceplate so I could turn it on a lathe. That's the other nice thing about plastic. It doesn't make any dust while you're working it. Or maybe it does, but I just can't see it. It's probably a good idea to wear a mask. It's probably recommended. So I turned it down to 3 inches outside diameter, and then I began carving out the inside very carefully. I don't want the pipe to fit too tightly because I don't want it to crack the plastic. Eventually I got it to a point where I could fit them together smoothly. I then cut the plastic ring to the same width as the pipe, 0.6 inches. I'm sure there's a better way to figure out where to mark the plastic ring so I knew where to cut it to fit inside the splines on the bowl on the engine. But after trying several methods, tape measure, ruler, marker, Sharpie, yawn protractor, and micrometer, I found the best way was to tape the ring onto the bowl itself with the tape covering the areas that needed to be filed, then spray painting the plastic ring. Anywhere there wasn't paint, I could file down. After the paint dried, I measured how much plastic needed to be filed off and drew a ring as a reference line so I didn't file it down too far. I filed some and test fitted and filed some and test fitted again until it fit just a little loose inside the bowl, just to give it some wiggle room, about 1/16 of an inch. The plastic ring will expand some when the engine is running because the plastic piece will be in contact with the bowl on the engine, which, after the engine has been running a while, will heat up and transfer some of that heat to the recoil. At this point I fitted the pipe into the plastic ring and started the engine, checking to make sure everything was running perfectly centered. Once I knew everything was perfectly centered, I had to make splines for the pipe that would notch into the plastic piece. Because the bearing is going to be pulling on the pipe, which is going to be pulling on the plastic ring, which is going to turn the engine over, I decided to make 6 splines so it would exert an equal force all the way around the plastic piece, which should decrease the likelihood of the plastic piece breaking while turning the engine over. If that makes sense. I think it does. I made 6 splines from an old T-post. I cut each spline to the same width as the pipe, 0.6 inches, and I ground each spline down to about 3/16 of an inch square. I spaced all 6 equally apart around the pipe and welded them on, just tacking the ends. Then I filed down the welds on the ends so the edges were all square. I set the now spline pipe on the plastic piece and marked the center of every spline so I could file in the keyway slots. Again, I put the plastic piece and the pipe, and now the bearing in the bowl on the engine, and started it. Seeing that it all ran true, I proceeded to put the final details into the pipe. I put 4 small tabs on the inner side of the pipe to keep the pipe from moving when the engine is running. On the outside of the pipe, I put 4 more tabs to keep the plastic ring from traveling out when it's spinning, when the engine's running. I also JB welded the plastic ring to the pipe. There were some gaps between the splines on the pipe and the keyways in the plastic ring, and I was worried about pulling unevenly on the plastic ring and cracking it. The JB weld filled in the gaps and welded the plastic to the pipe. Now that the inside of the recoil is done, I just need to make an axle, pulley, and a housing for it. I made the inner piece for the bearing from another pipe I found. It was large enough to allow me to keep a small step at the base of the pipe to keep the bearing seated in place against. I also made the seat for the bearing slightly longer than the bearing is wide, about 0.6 inches. Under the bearing seat, I left another step. This one would be for the pulley to mount on. I cut this down to about 7/8 of an inch. This piece had to be keyed to the bearing, so I filed in a keyway and ground a key for it. The axle for the recoil had to be lathed to fit perfectly inside the inner bearing piece. I left it a little long so I could cut it down later to the right length. I also left the axle with a slight step at the bottom. This step is where the pulley is going to turn on. It will also act as a stopper because I need room to put the coil spring underneath the pulley. The outside of my plastic ring is 3 inches in diameter, so to give me about a 1/4 inch of space between it and the inside of the pulley, I made a 3.5 inch diameter ring from a long strip of sheet metal. I didn't cut it down to width first because I also needed a 3.5 inch diameter ring to hold the coil spring on the back of the pulley. I found an old brake rotor that had a center on it exactly 3.5 inches across, so I C-clamped the steel to it and gently bent it around the rotor. After cutting it off and welding it into a ring, a width of 0.75 inches, a measurement I got from combining the width of the bowl on the engine, about 0.6 inches, with the step under the seat on the inner bearing piece, which I left about 1/4 inch wide. A quick look in the repair manual told me the pulley had a diameter of 4.5 inches, the convenient size of an angle grinder disc. I traced the inner hole of the disc and the outside of the disc onto 2 pieces of scrap sheet metal. The inner hole on one, the base plate, had to be at least the same size as the bottom step of the center bearing piece, which was 7/8 of an inch. I ground down the outside of both pieces to 4.5 inches. The other plate, I used a welder to burn a 3.5 inch hole into the center to fit around the center steel ring of the pulley. I used an angle grinder with a worn out grinding disc on it to grind out the inside of the plate, double checking every now and then to make sure I didn't grind it too large. Then I welded the base plate for the pulley onto the inner bearing piece. I noticed when spinning the base plate for the pulley around the axle that it spun slightly off-centered. So instead of centering the steel ring on the base plate, I centered it by spinning the plate on the axle and making sure it spun perfectly centered. After welding the first plate, I ground down the welds that I made on the inside of the pulley, again trying to make it as smooth as I can for the rope that I'm going to put around the recoil. Then I welded the other side of the pulley tight to the ring. I also drilled a hole in the back of the pulley to tie the recoil rope through. I welded the other half of the ring onto the back of the base plate. The coil spring needed a notch to hook into, so I cut a slot into the edge of the ring. I used another small piece of sheet metal to make the inner ring for the coil spring to hook into, basing that measurement off the ring on the recoil the spring came from. Sometime around now, I test fit all the pieces I had so far, and decided that the final axle length should be a little longer than the inner bearing piece. That way, after I drill a hole in the center of the axle and thread the hole so I can tighten a bolt into it, the washer under the head of the bolt will have some clearance between it and the center bearing piece, which needs to move independently. Most recoils have a spring holding the parts of the recoil down in place, but with mine, I don't have enough room to install a spring. I'm relying on allowing the center bearing piece to move about a 32nd of an inch with some axial play. I test fit everything to make sure all the pieces fit together. Seeing as they do, I put the recoil on the engine to double check that everything lined up exactly as it should. The housing was something I made nearly a year ago. I knew the pulley was 4.5 inches from reading the manual, so I bent a 4 3/4 inch ring and welded that onto a plate I traced from the mounting surface of the engine. Then I had to drill the bolt holes around the housing. Since my 3-wheeler has a neutral indicator, I had to drill the hole for that first, so I could actually press the housing to the mounting surface. I eyeballed the right spots, marked with a Sharpie, and drilled the holes slightly bigger than the bolts, just in case the holes were a little off-center, so the recoil could be moved side to side if I wanted to before I finally tightened it down. I also needed a hole drilled in the casing for the rope to run through, so I did that. Then I welded on the piece I cut off of the axle. This would serve to increase the surface area that the rope ran on as it paid out from the recoil. It was about the right length I wanted, and very convenient. After welding it on, I filed down any sharp edges. The last piece I needed to make would be a second external spring. When you turn an engine off, the crankshaft always stops moving on the compression stroke, and then it usually bounces back some. The downside of using a one-way bearing, when the engine turns backward, it's going to try and turn the recoil backward as well. The first, more basic spring I tried was made from a rod bent in half and welded to the casing. I thought the rods were a little too hard and not quite springy enough. So, version 2, I used an old sawmill blade that I ground the teeth off, then bent it into an S shape. The idea with the S shape was that when the engine turned back and pulled down on the spring, the hole through the spring would stay lined up with the hole in the recoil housing. Otherwise, as the spring pulled down, it would move back away from the holes, so the recoil rope wasn't lined up anymore, and it was kind of pulling crooked. After putting all the pieces together, putting it on, and testing it, I could finally paint it. There was one last step before I called it done and tightened it onto the engine for the final time. I started the engine and loosened the bolts holding the recoil so I could make sure the recoil wasn't pulling crooked or vibrating excessively. As you can see, if I lift the recoil, it vibrates. If I push it to either side, it does the same thing. I found the middle area where there were no vibrations, and finally tightened the recoil down into place. The main reason I built this recoil was just to see if I could, and as an engineering challenge. And, well, the whole thing only cost me $14 to make, so that's a plus. When I first started this project, I thought I'd have it done in a week, but it ended up taking me more like a month. I spent close to 100 hours building this. The entire thing was built by design, then redesign, was design, redesign, over and over, trial and error, till I finally got it right. If I knew exactly what I was building when I started making it, I could have made it in a quarter of the time or less. Basically, for the entire project though, I had to think 10 steps ahead. If I alter this one piece now, I'm going to have to figure out how to alter every other piece after this to make sure it fits with that piece so it doesn't change too much that the recoil doesn't work anymore so everything still works and fits together. Yeah. Now I know why my computer kind of freaks out whenever I take a video clip, slice it into a dozen pieces, add a few special effects every video, time that whole thing to a song, then accidentally delete the video file from its folder. Suddenly the computer just has no idea what it's doing anymore. Another thing, I'm not sure how great the design of spinning the outside of the bearing is. I took the recoil back off after driving it some, and some of the grease from the one-way bearing, even though it was supposed to be a sealed bearing, leaked out and covered some of the other spinning recoil parts. So I'm not sure how long that's going to last. And truthfully, I cannot recommend that anyone builds a recoil from scratch like I did, unless you're a much better engineer than I am. Some men look up and down, left and right, but men like us are different. We are visionaries.